Hello 9H kids. I'm going to make a video of myself going over the test that you had while I was out to make sure that all of you understand it. So let's start with the very first question. What can you assume for free, kids? Yes, reflexive. So then you can see the two triangles are congruent by side, side, side. In the next problem, they name the triangles in corresponding order. Remember, whatever order that these triangles are named in, it's corresponding order. So the answer would be choice 3 because K is in the same position as M and L is in the same position as O. For question 3, you have segment AC bisecting this angle. Therefore, those angles are congruent because an angle bisector splits an angle into two congruent angles. Reflexive, a gift. So the side is not included. Therefore, it's angle, angle, side. Taking a look at question 4, you are given the following information. Seems to have gotten a little misconstrued here. Oh, so, all right. I'm having trouble reading this one. I'm not sure why it downloaded incorrectly. Which combination cannot be used to prove that two triangles are congruent? So let's think about it. Here we can make any two triangles that we want. So we have triangle GHI, and we have triangle EFD. EFD. So I drew them in corresponding order and corresponding positions. So if you have two pairs of angles congruent, you can't have three sets of angles congruent to prove that triangles are congruent. So 1, 2, and 3 would not work. That is not a choice, however. So I believe that we have EF here, and this must be GH. So if we have those congruent, let's look at the ones that have Roman numeral 4. There's 3 choices with Roman numeral 4. And then let's look at choice 1. If we combine that with 2, H and F, and V, which is these sides congruent, this would be angle side side. We haven't established right triangles, therefore that is your answer. You cannot have angle side side. Okay, is illegal unless we have right triangles. Okay, in question 5, refer to the figure below. Which of the statements is true? So let me scroll through this. All right, so we have right triangles. Hypotenuse leg is not a choice. We have that these sides are congruent. We know reflexive automatically. So therefore, this is side, angle, side. Hypotenuse leg was not a choice, and they didn't give us information about the hypotenuses. Question 6. We have AB is congruent to CD, and we want to know what we could prove. Well, we could do the addition property. We could add BC to both of these, so we could have AB is congruent to, we could prove that AC, is congruent to DB by addition, because we could add this little piece to both. We want to prove that lines are parallel, so there's many different ways of doing that. We could have AIA congruent parallel lines, corresponding angles, parallel lines, corresponding angles congruent, all right? alternate exterior angles. So there's many different choices. So if you look at angle 3 and 4, that uses the theorem alternate interior angles congruent. Then you have parallel lines. Number 8, we were given these angles congruent. They marked them in the picture for us. So these two triangles are congruent, which means that we can use CPCTC. So we have AD and CD. Those are corresponding. In number 9, we have these intersecting. We automatically have vertical angles. Okay, if we had parallel lines, that would not be enough because that would just give us AAA. If we had AB and CD and then BE, that would be angle side side, so that would not be enough unless we had right angles. And then, which means these lines would be perpendicular. So we have E is the midpoint of AC. That's not enough. That only gives us side angle or angle side. But if we have bisecting each other, we have enough, because then we have side angle side. All right, let's take a look at a more outstanding longer proof. So we have that BD is perpendicular to AC. And we also have that BD is an angle bisector. Whenever we have two sets of angles, it's not going to be hypotenuse leg. So this is going to be an angle side angle proof. So number 1, you would put the givens. Number 2, I'm going to establish right angles. I'm going to take some shortcuts here. Angle 1 and angle 2 are right angles. That's because perpendicular lines form right angles. Okay, then we're going to put that those angles are congruent because all right angles are congruent. Line 4, we're going to put that angle 3 is congruent to angle 4 because of the definition of an angle bisector. You could also put the definition. You could put, if you wanted to, an angle bisector splits an angle into two congruent angles. And then we have BD is congruent to BD, reflexive. Of course, this could be put anywhere. This could have been put in lines 2, 3, and 4. Things can be moved around. These two have to come together as a pair. And then that's reflexive. So now the triangles are congruent by angle side angle. And then AD is going to be congruent to CD by CPCTC. Okay, so this is triangle ADB congruent to triangle CDB. And then AD congruent to CD. Nice, straightforward proof. Let's go to the next slide. So in this case, we're given BD is perpendicular to AC. We're also given that AB is congruent to CD. And our goal is to prove that AE is congruent to CE. So you can see what triangles those are in. So the perpendicular part is going to give us this. Of course, we have reflexive. And then we're going to have these hypotenuses. So right now, I'm focused on this triangle. Okay, so we're going to do hypotenuse leg for that triangle. Then once we have that triangle, what we could do is we could subtract ED. Well, no, we automatically have BE is congruent to BE. Okay, so let's look at these two triangles. Once we have them, we would be able to do CPCTC for these pieces. And then we would have this congruent to itself. And that would be enough to use CPCTC. So number one, we put the givens. Okay, number two, we're going to put that BD is congruent to BD. Reflexive. Property. I don't think I put property the last time. We don't really care. Okay, then I am going to have these right angles. So I'm going to call this angle 1 and 2. Angle 1, angle 2 are right. That's because of perpendicular lines, right? Form right angles. So then we can establish that we have right triangles. So triangle ABD, triangle CBD are right triangles. That's the definition of a right triangle. Feel free to write a triangle with a right angle is a right triangle. So now we can implore hypotenuse leg. You're only allowed to use hypotenuse leg after you have established that you have right triangles. So we're going to put triangle ABD is congruent to triangle CBD. All right, kids. Then we're going to use CPCTC to say that AD is congruent to CD. CPCTC. Now we're going to say that ED is congruent to ED, which, by the way, we could go put this up on line 2 if we felt like it. Doesn't matter. So that's, again, reflexive. Now, this is an interesting one. Before we say that these triangles, this triangle is congruent to this triangle, we need to see that this is going to be a side angle side. So we need to put that the right angles are congruent. So angle 1 is congruent to angle 2. All right angles are congruent. And so now we can establish that triangle ADE is congruent to triangle CDE by side angle side. And then AE is congruent to CE. CPCTC. That was a little more rigorous than the last one because you had to go forward and backwards, and you had to use hypotenuse leg. All right, question 6. Our ultimate goal is to prove that DC is congruent to AB. I like to start with the end in mind. We have E as a midpoint of AC, so that will give us this. I can see that we have vertical angles here. We also have that AC bisects FG at E. Okay, so we're going to get these triangles congruent. Now, once we do that, we certainly will be able to see that these angles are congruent. I'll erase this in a moment. All right. And let's see what else we have. Okay, we have those sides. We would be able to get these angles congruent. I meant on the inside. So you can see I plan it. This is the first time I've seen these questions, so, you know, I plan it ahead of time. That would end up giving us linear pairs, supplementary, and then we would be able to get these angles. Vertical angles are congruent, linear pairs, and then we would be able to get these triangles congruent, these pieces congruent, this, and then likewise this and this, and then we'd be able to add. Okay, so let's do it. And there's more than one way of doing it. I'm just doing it off the top of my head in one way. I'm not going to do it in every which way possible. So number 1, we put the givens. Okay, so number 2, I'm going to do both sets of vertical angles. Why not just take it easy, and I'll call these angles 1 2. I'll call this 3, 4. I'll name this angle 5, 6. Don't like the way that 6 looks. On your end, it just disappears. And then 7, 8. All right. So we're going to put angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And that's because vertical angles are congruent. I'm going to use this midpoint business and this bisector business. So AC is has a midpoint. So AE is congruent to CE. You could put definition of a midpoint, or you can write a midpoint splits a segment into 2 congruent segments. Splits a seg into 2 congruent segs. All right. So then we have this FG being bisected, so that gives us FE congruent to GE. Feel free to write definition of segment bisector, or you can write the definition. We'll write what it means in this context, right? So a segment bisector splits a segment into 2 congruent segments. All right, so now I'm going to put that those skinny little triangles are congruent. I'll outline them in yellow for you. So we have triangle AGE is congruent to triangle CFE. And you could see that the method would be side angle side. So then I'll use CPCTC. Oh, why did I write 6 here? So for CPCTC, I'm going to put that angle 5 is congruent to angle 6. I'm also going to put that, let's see, I'm going to have linear pairs there. All right. And then I'll use addition at the end. Okay. So we have FC is congruent to AG. Starts to get a little crazy with all the marks, right? All right, now I have to establish linear pairs. Angle 5 and angle 7 are supplementary. Same thing with angle 6 and 8. And that's because linear pairs are supplementary. Then we can establish that angle 7 is congruent to angle 8. And that's because supplements of congruent angles are congruent. All right, so now we have those triangles are congruent by angle side angle. So triangle DFE is congruent to triangle BGE. By angle side angle. I'm going to stop marking the picture because it just looks like a disaster. Then we can use CPCTC to conclude that DF is congruent to BG. Then we'll use addition. So we have DF plus FC is congruent to BG plus GA, semicolon, and put the answers, DC, AB. I'm sure there's more than one way of doing this one. When they get longer, there usually tends to be different ways that you could do it. All right, let's take a look at the last. So we have all this perpendicular business, and our goal is to prove that OG bisects RGL. So we want to prove that these angles are congruent. Now, we're given all this perpendicular business. We need to get to those angles. All right. We're also given OK. That's going to be the biggest clue. Limited information is actually the biggest clue. So we're given this, right? And we're given all this perpendicular. We're given vertical angles here automatically that we can assume. So we have OR is perpendicular. So that would be a right angle. This would be a right angle. We'll see if we need them both momentarily. All right. So we will indeed need both. Our goal is going to be to get this pair of sides congruent after we prove those triangles are congruent by angle, angle, side. Those triangles, I mean this one and this one. I'm going to do those by angle, angle, side. Then I'm going to do CP, CTC. Then I'm going to do reflexive. And when I do reflexive, I'll do, oh, is that going to be hypotenuse leg? Let's see. Yes, I'll use hypotenuse leg. So here, I'm going to establish right triangles. And I'll use hypotenuse leg. So that's how I do proofs. I plan it out first, kids. Then I actually do it. Number one, given. I think the big mistake people make with proofs is they try to, just do the proof, but you really have to stop and plan it first. I'll call this angle 1, 2, 3, 4, 5, 6, just because it is going to save some time. You don't need to have me name them any other way. All right, and then I'll call this 7, 8. So I'm going to put the vertical angles. Angle 1 is congruent to angle 2. Vertical angles are congruent. Then I'm going to put these right angles. Angle 3, 5, 4, 6 are right angles. Okay, but I want to establish in those yellow triangles that angle 3 is congruent to angle 4. Whereas in those green triangles, I want to establish that triangle GOR and triangle GOL are right triangles. So it depends on what theorem you're using, the direction you go. So this is from perpendicular lines, form right angles. All right, these angles are congruent because all right angles are congruent. These are right triangles because of the definition of a right triangle. Okay, now I'm going to put that those yellow triangles are congruent. Triangle KOR is congruent to triangle JOL. That is by angle, angle, side. Then I'm going to conclude that RO is congruent to LO by CP, CTC. Let's not forget that OG is congruent to itself, reflexive. And then we can conclude that these green triangles are congruent. ROG congruent to LOG by hypotenuse leg. Then angle 7 is congruent to angle 8. That is by CPCTC. And then, of course, we can do this last one. OG bisects angle RGL. And that is the definition of an angle bisector. It splits an angle into two congruent angles. So you can either do definition, angle bisector, or you can write the definition. An angle bisector splits an angle into two congruent angles. Okay, so I hope this helped you kids. I will post it to Google Classroom, and you should definitely watch it and make sure that you correct your proofs. Okay? Thank you.